In this video, we are going to continue to work on the gradebook example. First, we'll do some housekeeping. So we can turn these to bold, for example. We can also add some borders to the table to make the information more readable. So draw a border. I'm going to draw a line here. I'm also drawing a line here to separate individual student grades from other calculations. I can also reformat these two cells so that only two decimal places are shown. So I right click on them, format cells, and I'm changing it from general to number, and I want two decimal places. So I click OK. Now it looks better. Remember that in the previous step we already calculated raw averages for every student. Now suppose test 1 has a weight of 40% and test 2 has a weight of 60%. And we want to calculate student final grade. So to enter a formula to calculate final grades, we start with an equal sign, like always, equals this grade times 0.4, which is 40%, plus the second one times 0.6. So 86 is the weighted final grade. Now to calculate the final weighted grades for the rest of the students, all I need to do is to grab this bottom right dot and release it, and I have final grades for the 9 students. It works perfectly, as you can see, but it's not very efficient. The problem is that you are repeating weights in 9 different cells. But what if later on you want to change the weight from 40 to 60 to say 30-70? In that case, you'd have to modify 9 different cells. It takes time and you are likely to make a mistake. So the solution is to write the weights in a separate cell and then reference that cell. So in K1, I'm going to write T1 weight, and in L1, T2 weight, and I know T1 weight is currently 0.4 and T2 weight is currently 0.6. Note that you can write 40% and it's treated the exact same way. So let's do it like that, and 60%. Now I'm going to delete the formulas that I made using the other method, and I'm going to replace them with a new formula. So again, equals, like any other formula, test 1 times test 1's weight plus test 2 times test 2's weight, and I press the enter button. So 86 is the weighted grade for. Let's now calculate weighted grades for the rest of the students. Let's try using the autofill feature. So I'm grabbing the bottom right dot and I'm extending it to student 2. Let's see if it works. Well, it's showing a grade of 0, which is obviously incorrect. This student has earned 90 on one test and an 85 on the other one, so there's no way his grade is 0. Let's investigate more to figure out what the problem is. Let's double click on it to identify all the cells involved. So B3, which is student 2's test 1 grade, times K3, which is this cell here. But this is incorrect, and this cell is actually empty and it's being treated as a 0. That's why 0 times 90, you're getting 0. And similar for test 2. So 85 times, again, 0 is 0, and 0 plus 0 is giving us the 0 that we are seeing. So this reference is obviously wrong. Instead of K3, what we want here is actually K2. And instead of L3, what we want is L2. So the question is why this problem occurs and if there's a way of solving it. To answer that question and to solve the problem, we should know about how Excel references or addresses cells. Let's look at this one. By default, Excel uses relative referencing or addressing. What the formula is saying in this case is go 3 cells to my left, get the contents, 6 cells to my right and get the contents and multiply them, and then go 2 cells to my left and then 7 cells to my right and get the contents and multiply them and then add them. This is why this is called relative addressing, because everything is relative to the cell that you are currently in. Now when you copy that formula to another cell, like this one here, the same thing happens. So this formula is now copied to a new cell, but it's still saying go 3 cells to my left and then go 6 cells to my right, grab the values, multiply them, and then go 2 cells to my left and 7 cells to my right, get the values, multiply them, and add the 2 values. Because the 2 values here are 0, then you're getting an incorrect answer. Now if I copy this yet to another cell, you'll see that the problem is repeating. So this part, the left part, appears to be correct, but then the right part where I keep my weights is not referenced correctly. Now how can I solve this problem? The solution is using what they call absolute referencing or absolute addressing. So to solve the problem, I go to the original formula that I wrote for student 1. Now I move my cursor to K2 where the weight resides and I press the F4 button on Windows. And Mac computers have an equivalent key for that purpose. So I press it once and I will notice that these dollar signs are now added. So the addressing for K2 has now changed from relative to absolute. I must do a similar thing for L2 because test 2's weight is in L2. So again, I move the cursor on L2 and press F4 just once. And I can see that now there's a dollar sign before the column label and there's also a column sign before the row number. And I can press enter and it's still operating the way it used to operate. But when I drag it, it's now working all right. So I'm going to click on this. You'll see that these two test grades are still relative, which is what I want. But test weights are absolute. So they're taken from the exact same cell, which is K3 and L3. If I click on this one, for example, the 2 test grades are correctly chosen from student 7 and the test weights are chosen from the right cells. Now if I were to change these test weights from 40% and 60% to say 30% and 70%, all I need to do is to change 30% and 70% in one place. So instead of modifying multiple places, I'm just modifying 2 places. Now I'm returning these weights to their original values, 40% and 60%.